Yeah, let me check. Yeah, it should be this one. So the minimum white tiles after covering with carpets. I think this is going to be a really famous problem. So yeah, we want to check the minimum white tiles after covering with carpets. So we have the number of the carpets and the length of the carpets. So let me yeah, just use this drawing to make an example. So for the carpet, we have how many of them, and we have the length of the carpet. So for example, we can cover from the left to the right side or from the right to the left side. It's gonna be the similar. It's gonna be the same problem. Yeah. So let's just imagine we're gonna cover it from the right to the left side. So this is a carpet. Yeah. So we can put it here. So this is one case. So this means for the last one, for the last prison, we're gonna cover it. Another case is we will not cover it. Yeah, and because this is a really famous problem, normally we can analyze it like that. Yeah, because this is the dynamic programming way to solve the problem. Definitely, it's gonna include all the different cases. Yeah, so the length of the carpet is 2. And we have two decisions. We can cover it and uncover it. So this means the big problem becomes a small problem. So for example, from here, it's gonna maybe from a small problem, and then another small problem, and another small problem until we solve the problem. Yeah. So this is the idea of dynamic programming. Yeah. So let's just continue. Yeah. So we're gonna set two variables. So the first one gonna be the a number, the number of the carpets. So the second one gonna be the position of the yeah, the second one gonna be the right position of the carpet. So it means here. Yeah. So if we're gonna cover it from the right to the left, we're gonna have two decisions. Yeah, we can cover this position. So for example, this position is here. We're gonna cover it, or we will not cover this position, so it's gonna move to the next. Yeah. So if we cover it from here, so what left behind? So this is the whole problem. Now what left behind is a sub problem. So it's gonna come from here, from the beginning, onto here. Yeah, because here we finished, and we consumed with the number of carpets we consumed 1. This means the number of carpets is gonna minus 1. This is the number of carpets. And if the number of carpets minus 1, what's going to be the position? So the position of the carpet, for example, this is a J, so it's going to be the position minus the length of the carpet. So this is one case. So we're going to cover this position. So another case is that we will not cover this position. So what happens if we will not cover this position? So this means the number of the carpet is going to be the same. Yeah, so for F, so the number of carpet is going to be the same. But what about yeah, let me think about it. Yeah, so the number of carpet is going to be the same, but the area, what left behind is just from here. Yeah, so it means the position gonna minus 1, and we need to plus the final one. It can be a 1 or it can be a 0. We are not sure. Yeah. So if it is the white tiles, so we're gonna plus 1. So if it is the black tiles, we're gonna plus a 0. So this is the idea. So there are only two formulas, and we're gonna use the dynamic programming to solve the problem. Yeah. And where is the edge case? So the edge case is the position. So if the position is less than 0, so definitely it's not possible. So we're gonna return 0. Yeah. Another case is the number of carpets. If the number of carpets equal to 0, so this means we cannot use the carpets anymore. So for example, here is what left behind is from here. So from here, we just need to check the number of white tiles. So for example, the number of ones. How many number of ones? Yeah, so those are the only edge cases we're gonna check. So let's just start coding. First of all, we're gonna turn this floor array into a list of map with integer with floor. Yeah, because it is a string, so we're gonna turn the string into a list of integers. So yeah, this is gonna be the first step. So the second step is that we're gonna define a BFS function, and inside I'm gonna prepare ing. So I'm gonna call the function. So I gonna be the number of copies, and j gonna be the length of the floor -1. So j gonna be the edge placing from the right to the left. So for example, if the copy here, so this gonna be the j. So if the copy is here, so this placing gonna be j. So the j gonna be the right side of the copied position. So this gonna be the definition of the j. So if the right side goes to here, I mean it goes out of the range, it's definitely we're gonna return a 0. So from here, if the right side is less than 0, so definitely it's not possible, and we're gonna return a 0. Now we're gonna check the two different cases. It's gonna be a minimum of f. We're gonna have two decisions. So yeah, for the last one, first of all, we're gonna first of all, let's just cover the place of this one. So what if we cover it? So the number of the copies, it is I gonna -1. What about the j? So if we cover it, so j gonna minus the length of the copies. So this is one case. Yeah, because we cover it, so what's left behind is nothing. We just cover it. But what if we will not cover it? So the number of the copies is going to be the same. Yeah, so this means we will not cover. So this means we will not cover this place. So for example, this is the first case we're going to cover this place. So the second case is that we will not cover this place. Yeah, so I gonna be the same. The number of the copies is gonna be the same, and what about j? So j gonna -1. So j gonna be shifted to the next place. Yeah, but we need to plus the floor of the position j from the right side, because we shifted from one position to the next. Yeah, so we need to plus a floor j. If it is 1, it means we find 1 which is not covered. Yeah, because definitely there's a sacrifice. If you were to cover it here, definitely there's going to be sacrifice. It may be better or it may be not. So if it is a white one, it is not better because we need to plus this one. Yeah, otherwise we're going to cover it from here, but the length is here, only reached here, but this length is reached here. Because we don't know which one is better, so we're going to return the minimum of the two. Yeah. Now, what is the other edge cases is that if we use up all of the copies, definitely this I cannot be less than 0. If this I reaches to 0, what are we gonna do? So we're gonna use this floor and to j plus let me think about it. Yeah, because this ij is the range. This j is the range from the 0 to j. It is inclusive. So here we're gonna use a j plus 1, and then we're gonna count how many ones, because this is gonna be the white tiles. Yeah, I mean this problem definitely there's a pattern, and this is a very famous problem. How we're gonna analyze the problem is gonna be dynamic programming, and we're gonna analyze it by covering the last one, not covering the last one, and we're gonna shift it to the left. I think that's all about it. What about just running the code? As you can see, it works. Now let me just submit it. Yeah, as you can see, it works. Although the speed is not so fast, but we can improve it. But the time complexity, it's gonna be I times j, which is gonna be 1000 times 1000. So this is okay for Leetcode. But what if we just improve a little bit? Because for this j, it's the number of copies. Yeah, even though we have this, because this j is the position. Yeah, maybe, for example, we're gonna reach some places. We can directly return the final answer. How can we return it? We can use this j. If this j is less than the number of the copies times the copy length. So we are sure that it's not possible. We are sure we can cover all of them, so we're gonna directly return 0. Yeah, so how to analyze? Let me use an example. Yeah, let me use an example for this case. So for example, we have like I don't know, maybe it is just always white 1 1 1 1, and here maybe a 0. It doesn't matter. But while I'm at this position, this is the j, and what left behind is there are 2 copies and the copy length is 2. Yeah. So if I'm at this position, definitely I have 2 copies and I have the length of the copies is 2. 2 times 2 it is 4. So definitely with a length of 4, I can cover all of them. No matter it is a 0 or 1, it doesn't matter. So I'm gonna return 0. It means I cover all of them, and there's no white tiles that is left behind. So I'm gonna return 0. So if j comes to here, yeah. Yeah, let me use this j here. If j comes to here, it means the index is 3, and this one times this one, it is 4, so 3 is less than 4. So definitely from j, this position to the left, we can cover all of them. So this is just a shortcut, like the trimming of the binary tree. Oh, it didn't work. Let me think about it. Oh, it is not the number of copies, because we use the sum of the copies, and I is the number of copies, so we're going to use I. Now let me just run it and submit it to check if it works. Yeah, now as you can see, it works, and it improves a little bit. It becomes 2 seconds. Yeah, I think that's all about it. Thanks for watching. See you next time.